Hello,
Hey.
everybody. We are back. It is AASLR, and we're back. We're here with Carrie Roberts, who is one of our Antisyphon instructors, and I'm going to drop the link to her class right now so I don't forget it. It's there in the chat, and I get a graphic for that. And there's the graphic, and now we've got that part done. We're just going to get right into it. So I'm going to hand it off to Carrie, and she's going to show you some neat tricks. Are you ready, Carrie?
I'm ready.
All right, bring it up your screen. There you go. It's all you.
Hey there. I want to introduce you a little bit to Atomic Red Team, and we're going to take a look at some of the techniques in Atomic Red Team and the procedures. So Atomic Red Team is a library of scripted cyber attacks. So if you are a network defender and you're wondering about certain attacks you've heard that malware uses certain built-in operating system executables as in tricky ways to download the files they need for their attack, and you wonder, are you prepared to defend against that? Would you detect some of those techniques? Well, to do that, you need to have some procedures to run, and Atomic Red Team gives you those procedures, those actual commands you need to run to emulate the behaviors in that malware. So the library, Atomic Red Team, is here. It's on GitHub, and there's a nice README here and a wiki that tells you about it, and a bunch of files. And the library of procedures is in this atomics folder. The other stuff you can ignore for the most part. But before we jump into the library here in the atomics folder, I want to take a baby step backwards and talk just a tiny bit about MITRE ATT&CK, because everything within Atomic Red Team ties back into MITRE ATT&CK. So here we are over on the MITRE ATT&CK website. MITRE is an organization that developed this matrix here. So we have this matrix where they've defined all the tactics and techniques that have been used by attackers and malware across organizations across the globe, and they've categorized it to give us a common language for talking about those tactics and techniques. So here in all the cells of this table, so each of these I'm hovering over are techniques, and each technique has a T number. So T1037 is the boot or logon initialization scripts. So that's a technique that attackers can use. And so each of these techniques are in certain categories. The categories at the top are the tactics. So tactics are just groupings of techniques that are similar. So we have tactics across the top, techniques going down. And then if we click on one of these, we can dig into the details of a certain techniques. So we're going to be looking at a technique under the command and control category called Ingress tool transfer. It's technique T1105. So I'm going to jump back to Atomic Red Team and show you how technique T1105 is shown in Atomic Red Team. So I go into this atomics folder and I see a bunch of T numbers. These are MITRE technique numbers that we just saw. So I said we're interested in T1105, which is Ingress tool transfer. That's what we're going to look at today. And I'm seeing how well I can count here. T1105. So in T1105, I can click on this markdown file to learn what scripts are, what Ingress tool transfer techniques are scripted here. And here I see a list of atomic tests. There's 1 through 28. So there's 28 ways or procedures you can use to do Ingress tool transfer the way the attackers are using them in the world today. So we have a copy of the MITRE ATT&CK description here. But I want to show you, I'm also highlighting a cool tool that I did another video on that you can check out on the Antisyphon website. But I have a Chrome extension installed from MITRE called the Attack Power Suite, and it gives you the ability to jump right to MITRE ATT&CK for certain things you highlight. So here, T1105, I'm going to highlight that and right click and go to Attack Powered Suite, that extension I have, and I say go to T1105 in Attack. So if I want to learn more about Ingress tool transfer right from MITRE ATT&CK, I can jump there using that extension, which has a lot of other nifty tricks that you can learn about in that video, demo video. But here it talks about adversaries using built-in tools, so things built into the operating system like certutil.exe, built into Windows, signed by Microsoft, highly trusted, supposed to be there, not unusual to see it being used. And it allows us to download things when maybe our tool wouldn't be allowed to run in our tool as an attacker. So here it talks about different ways that attackers are bringing their tools in with built-in tools. For example, Art40, or here's a group, APT41, that you can click on and learn more about within MITRE ATT&CK, but APT41 group uses certutil to download files for their attack. So there's an example. We're going to be looking at certutil today. And then another one, Astaroth, uses certutil and bitsadmin, two tools built in right into Windows. So now, let's see. When we scroll down, also in MITRE, we can read some things. There's a lot of groups and software that use these Ingress tools. Holy smokes, super long list. But at the bottom, there's some mitigation and detection ideas. So you can read about those there. But we're going to jump back into emulating these attacks with Atomic Red Team cyber attacks. So here we have 28 different tests we can choose from. So these rsync ones and SCP ones, if we take a look at that, it says that this scripted cyber attack is meant for Linux and Mac. So actually the first one in here that applies to Windows that we're demoing today is test number 7. So I'll click on that and jump down to test number 7. So this test uses certutil, a Microsoft signed on Windows by default utility to download a file from the internet, which of course attackers like to use that to bring in their tools. So here, to run this scripted cyber attack, all we need to do is run this command. But it's not quite that straightforward because we see some special syntax in here. We see squiggly, hashtag squigglies. Sorry, I'm trying to zoom in and it's not zooming. There we go. Whoa. We see the, we see the hashtag squigglies and then remote file. That refers to a variable. So this whole thing needs to get replaced by some arguments, some variables up here. Remote file by default gets set to this license file on Red Canary's Atomic Red Team repo. It's not an attack tool. It's really just a license file, but it's demonstrating how certutil can be used with certain options to download files to a local path. So the local path in this case by default will just be the current directory, atomic license.txt. And these input arguments can be changed at runtime. So we could swap out the defaults for whatever value we want. So if we wanted to emulate downloading an actual bad tool instead of just a license file, then we could change out that variable. So instead of copying this into Notepad and replacing these variables myself, I'm going to use a tool called Invoke Atomic Red Team. It's a PowerShell tool that knows how to read this library of scripted cyber attacks and follow the instructions. So it's going to run those commands. It's going to swap in those variables. If I back up one level in GitHub to just Red Canary Co., and instead of going into Atomic Red Team, which is the library, I go into Invoke Atomic Red Team and click over on the wiki. I can learn all about how to install, use and install Invoke Atomic Red Team. So I've already got that installed over here. So I have this function available to me, Invoke Atomic Test, and then I give it my technique number, which is T1105. And then I have some options. So instead of just running all the tests in T1105 off the bat, I could say before you run it, just show me the brief details about technique T1105. And we remember over here on the web, we were back in T1105. Here we saw there's 28 tests here. And it starts with 1, but when we listed the brief details over here in Windows, it started at test 7. That's because the execution framework knows that we are on Windows, so it's not showing us those tests that don't apply to our platform. So here we see only 7, 8, 9, and maybe skip a few numbers in here if it doesn't apply to Windows. So today I wanted to take a look at several of these tests for Windows using built-in lib canaries. So you might see that written LOLbin. So live off the land, binary being an executable file. So live off the land is some executable that comes on the operating system that the attacker doesn't have to bring. So less likely for them to get caught using those tools potentially. So we're going to look at certutil download. So I'm going to show you this test over here. Well, it's the one we were already looking at. It's all it's going to do is call certutil and give it the parameters it needs to download a remote file to the local machine. And one option we have with invoke atomic test, actually I'm going to open up another PowerShell window so we can leave that one showing our tests here. So if I say invoke atomic test and T1105, and I can say -7 for test number 7. And then instead of show details brief, I'll just say show details, which is the full details. And you'll see that we have the same information we saw on the website here. So we have, it's just laid out a little different. We have the attack commands here. It says to run it with the command prompt. We don't have to be elevated. It's all the same information. We see this exact command right here with the variables highlighted in red. And then we also see command and then with inputs. So here we have remote file replaced by that URL, which is the default value for a remote file. And then we see local path replaced by that variable atomic license.txt, which is right here. So at this point, we could copy and paste this right into the command prompt because that's where it says to run it, and we don't need to be elevated. But since we have this execution framework and invoke atomic test here, we can just tell it to do it. So if we make the same call as we did before without any of the show details options, it'll just run that test. So here we go. And it says, we found something bad in your script, and AV comes up, the Windows Defender comes up, and it says, we're blocking something called seprolod.a. I don't find these names super helpful, but Windows Defender, it looks like out of the box, has caught on to people using URL cache split and decided that's really not that common and malware's using it, so we'll just block it. So we're kind of covered there. We could, as a defender, I always go ahead and run the test again with Windows Defender disabled, because in my experience as a red teamer, there's always a way around all the preventions. You know, you can disable Windows Defender 20 different ways. You can bypass AMSI. You can use some obfuscation. And so we want to be sure that if the primary defense of preventing this doesn't work, will we at least detect and know that it happened? So then I recommend turning off Windows Defender and trying that again. But for now, we see that Defender has it covered, so we're feeling a little warm and cozy about that. Now we're going to move on to test number 8, which is instead of using the URL cache option, let's show the details, it's going to use the verify CTL. So another option in certutil that lets you download a file. Let's try to run that one, test number 8, and it gets blocked. And if we click on that, we see, oh, now it's the B version. So we've got A and B. They're listing here for when we try to run that. Okay, that's cool. We'll continue on with our testing to see where we're not covered by default. So let's look at test number 9, bits admin. So for this test, it's just going to use bits admin exe, another built-in executable signed by Microsoft, with the transfer flag to download a file in the background. And this tool was built to do exactly this, download files in the background. So it's not likely to be blocked by AV because it's doing exactly what it's intended to do and what it has good use for. But then again, it really is not something super commonly used in an environment. Like you don't typically get your non-technical workers running bits admin on the command line. Therefore, we can keep an eye on it. And if we see that being used outside of a known good context, we can investigate if we've had an intrusion. So here let's see if Bits admin works out of the box with Windows Defender on. And it said it does. Let's see where it said it downloaded the file. It downloaded it to temp atomic license. So if we print that, we can see the atomic license there. So we see that worked. Let's see, does it have cleanup commands? Usually these tests have cleanup commands to get rid of any files it downloaded. This one's missing it. It's an Atomic Red Team's open source. We have over 265 contributors, so you can get in there and you could add in that cleanup command so that people could clean up after that and repeat the test. Most of these do have cleanup commands. So next we have PowerShell. PowerShell is definitely built into Windows, definitely used a lot by malware. There's a lot of options in PowerShell to download with invoke web requests or .NET functions. I'm not actually going to run that one. It works, no big surprise, it works and doesn't get blocked by AV, but it's also used a ton by legitimate processes. And so it's a more difficult one to keep an eye on because we have to ignore the good and pull out the bad. So I'm just going to skip that because we know that's going to work. Let's see, file download with Windows Defender MP command run. So there's a tool that comes with Windows Defender that you can actually use as an attacker to download a file. So let's take a look at that, test number 13. So this test is just going to change directories into the Windows Defender directory and do MP command run, download a file from this URL, again to temp atomic license file. So let's remove that file. And then we'll run that test. And Windows Defender doesn't like that. It quarantines it and calls it MP util abuse. So looks like Windows Defender isn't a big fan of the use of their MP command run.exe for downloading malware. Okay, so maybe this isn't our top priority since we have some preventions out of the box, but what else might work? Another version of downloading with PowerShell. How about downloading with finger.exe, that old program Finger, still around on Windows? We can download a file with it. So we could look at test 16. And so here we have the command is finger, and then the attacker would actually, this is for, I think, this is a file download using fingers. But this looks more like exfil, where you tack on some base64 data and then make a call to a remote host, but the default is just the local host. This test actually, since we don't have localhost listening for that communication from fingers, it actually, the communication doesn't happen, but it does exercise finger with those parameters, and we could see if we can detect that in our environment or if there's any legitimate uses for it. Maybe we could just say, hey, I want to know if anybody uses finger.exe because it's just not that common, so it seems like a good thing to keep an eye on. Okay, and now this one has a little fun twist that we're going to look at. Download a file with this weird, I don't even know how to pronounce it, bunch of letters, built-in tool, again by Microsoft. The attackers could use to download their tools for their attack. So let's look at test number 617. So what this does is it's just giving us a path to the executable. It's built into C Windows System 32, and then it just calls that executable with the remote URL, and that downloads it. It downloads it to a weird location, which you can only see the folders in this location, local app data, Microsoft Windows iNet Cache IE if you change your view properties to show hidden system files. But here we are. Let's delete anything we have in here, and we can watch our files show up when we run this test. So we'll see our t1105.yaml get downloaded. Let's go ahead and run this test. And this is expected, and you can just ignore the dictionary file problem. But we see a new folder show up here, and in that folder is our YAML file that we downloaded from Atomic Red Team. So Windows Defender is not blocking that by default. So that could be something we could work on, keep an eye on. Really, not likely very common that folks are using this to connect to the internet and download files. So it's definitely something as defenders that we could keep an eye on. Okay, next we got curl. Curl comes on Windows built in now. Kind of handy, kind of not for the defenders, but kind of handy for the rest of the world. So as of, I forget where I wrote that down in this notepad, as of Windows 10 build 17063 and later has curl built in. So let's see if we can run test 18 and 19. Well, 18 and 19. 18 downloads a file and 19 uploads it with curl. So let's look at what it's going to run. So what's your prediction? Do you think if I try to curl a bunch of files from the internet, which is all these GitHub things, to a folder in users public music, do you think that Windows Defender is going to dislike that? Well, let's see. Okay, it looks like it downloaded all the files. We could look and see users public music. And so we have things in there. So that works. So we see that isn't blocked by default. So we could write our own rules for these live off the land binaries that really are just doing what they were designed to do in the first place. Your AVs aren't going to be blocking them ever, and that's clear. But for our defenders who have a knowledge of our environment and we know where we should expect to see the use of these tools and in what way they use and by what parent processes they tend to be used, we can add those things to an allow list and look for anomalies outside of that. So if we see curl used on by a user who is not a technical user on their machine, then and by a process that's unusual, then that could be an alert for us. Let's look at what the upload file does. Probably looks really similar. Test 19. So test 19, yeah. So it's uploading with various command line parameters, files. I actually didn't run this before, but I assume this is going to work. Where's it going to upload to? It's going to upload to example.com. So I guess example.com is going to get these files and it's not going to expect them, but let's see what it does. So it says it can't open ctemp. Actually, this is a good example to look into. So let's look a little closer at the upload. So it's going to try to upload ctemp atomic test file. Well, we don't have that. Here it says curl must be installed. Yeah, we have it installed. And it also says the file to upload has to exist. So we have some scripts, some commands here that will tell us if we meet this prerequisite. So if I run this with the check prereqs flag, it'll actually would have told me if I would have done this, that I don't meet one of their prereqs, which is I don't have this atomic test file created, which I'm then going to try to upload. So prereqs is it not met for the curl upload file. A file must be created to upload. So it says you can get that with get prereqs. So this get prereqs is going to just put this is an atomic test file into ctemp atomic test file. So now I can just run get prereqs and then it will create that file. And now everything's happy. And we can run this test without getting those errors. Okay, everything's not quite that happy. Okay, so it looks like I have a little work to do on the atomic to fix that. I'll just create this myself manually. Oh, where'd it go? Copy and paste in PowerShell is hard, I'm telling you. Oh, I don't have a temp directory? Well, we could update that atomic to make the temp directory if it doesn't exist. And then I think this would all work. Let's try to get the prereqs again. Okay, so it says everything's ready to go. Now we take off the get prereqs, and it's going to upload those files out to example.com. So we could watch in our environment for uploads coming from curl, going to external sites, and so everything worked there. I want a couple more things we take a look at before we call it a day. I want to look at using Certreq, another Microsoft built-in binary. It's kind of almost unlimited the options here, but it's good to keep an eye on these commonly used download methods by malware. So let's look at test number 25, and we'll show the details. This is just going to use Certreq with post config, and you give it a remote file. And you download a file to your local machine. So let's see if Windows Defender lets us do this. Yeah, so it's happy. It downloaded a file. Where does it download to? Atomic license, and everything looks good. So one thing I wanted to remind you is, even though Windows Defender out of the box have blocked some of these scripted cyber attacks, a lot of times those signatures are very weak. Like, they might be looking for a certain word in the command line, like literally red canary co. Now, this is just a test, and we happen to download stuff from the GitHub repo that has red canary co in the name, in the URL, but attacker is going to be downloading that from some other location. And so realistically, the defenses need to be based on something besides just a certain string found in the URL. To demonstrate this, I'm going to show you this one test we ran with imewd blah, blah, blah. We're going to run that by hand. So I have this command here. We're going to take it in here. So here we are. We're invoking the and in PowerShell just invokes this string as a path to a file. So it's going to invoke that executable. And we're going to pass it this URL, which is just this YAML file on Red Canary. Let's do that. And it says, this script contains malicious content, has been blocked by your antivirus software. So we think to ourselves, I don't need to worry about attackers using this executable to download files because it's blocked. Well, when in reality, Defender is just looking for the combination of IME blah, 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 exe on the same line as Red Canary Co. So I have a copy of this GitHub repository forked or just copied over to my own repository. So same file, different location, over in CLR2 of 8. So if I just change that, same file, being downloaded the same way, but from a URL that doesn't contain the letters for Red Canary Co., then it works just fine. So this is expected. Remember, but if we go and look in the folder, we see that file here. Here, let me repeat that. Get rid of those. and run this again. So it's just a reminder that it's a good idea, even if your preventative controls block something, to tweak the parameters a little to see if it's a weak detection, and also to assume that the prevention can be subverted, and to make sure that even if you don't prevent, you can still detect that these things are happening. So we take that, and now we see our T1105 file got downloaded just fine. Okay, that's what I have for you today. We've taken a look at Atomic Red Team, the library of scripted cyber attacks that has all of their procedures or scripted cyber attacks, all linked to MITRE technique numbers from the matrix. And we looked at using the Invoke Atomic Red Team PowerShell script to read this library and execute it. Hope you've enjoyed this little walkthrough and learned a little bit more about Ingress tool transfer with LOLbins, live off the land binders.
That was a lot of stuff. That was great. Any comments, Serena? I think you're muted.
Hello.
There you are.
I think we have a couple questions. Let's see here. So is this done internally for finding vulnerabilities?
Yeah, this is what best done as a purple team exercise, where either the blue team just goes and emulates these scripted cyber attacks to quickly see what do we have covered, what don't we, what could we add, where's our detection gaps, or in the blue team in combination with the red team doing kind of a above board, like red team telling blue team, I'm trying this, and this, what do you see? So collaborative purple team effort, done on the internal network. Yes.
Okay. Christopher says, so is this something you would use on your network if it's been exposed to malware, or something you just do as a preemptive measure, or both?
This wouldn't help you after the fact unless you're looking for where are my gaps, where this breach could have come from. This is something you want to do ideally constantly. So maybe you validate your detections for all these things this week, and then you do that again next week, and then you do it again next week. And since this is automated, this can all be done. I was invoking all of these by hand. I was saying invoke this, invoke that, but all that can be thrown into a simple PowerShell script of all those commands, and then you can just have this thing firing around the clock, and you could keep an eye on your detections. And if things start dropping off, then you know that something broke. There's so many things that can go wrong in our detection pipeline, from our policies to people's procedures, certificates. The reasons are endless that something doesn't work the way we think it does. So validating this continuously through automation is ideal.
Cool. Does anybody else have any questions? If you do, throw them in the chat. And again, Carrie's, I think we already linked in the chat. Maybe Ryan can find it again.
We can throw that in there again.
Antisyphon class. If you're interested in learning more about Atomic Red Team. And I know Carrie has mentioned this before, because it's an open source project. Are you looking for additional maintainers, or?
Yeah, contributors and maintainers. Yes, we've got about 8 maintainers, both inside and outside of Red Canary. It is open source community project. It's growing every week. I was just noting that when I started teaching Atomic Red Team class 2 years ago, the Slack workspace had half as many members as it does now. There's over 4,000 members today, where you can join and talk to like-minded attack emulation folks about all things attack emulation and Atomic Red Team. So it's really exciting to watch how this is growing. I'm one of the maintainers of the project, so I approve all of the additions to the Windows platform. And it keeps me busy week to week, just keeping up with all the additions and the new attacks that we can emulate, and playing with those. yeah, so that Atomic Red Team class, I go in more detail about Atomic Red Team, the library, and various execution frameworks. So today I showed the PowerShell execution framework, but there's also some C2 style, command and control style frameworks like Prelude Operator and Caldera. And there's even a Vector, which is a purple team reporting tool, but also can build these scripted cyber attacks into individual executables that you can just take around and spot check things in your network, and all you have to do is run an executable. So there's lots of neat stuff and things to learn about putting attack emulation to work for you in your organization.
Awesome. And then just for people who are watching us on Twitch or YouTube, just a reminder to subscribe or follow if you're on Twitch, like the video, all that stuff. And then this will be on our YouTube page after this is over, so that you can watch it again if you want, or watch it later if you need to.
Yeah, one comment on that reminds me, I've started an Atomic Spotlight series, which is going through one or more atomics, just like I did today, to get you more familiar, because there's over 800 atomic scripted cyber attacks in this library, so it can be overwhelming. So this just takes a little piece of it and makes sense of a few attacks and why we care about them. So this is my third video. So every week I'll be releasing a video on an Atomic Spotlight playlist on Antisyphon YouTube. So if you want to go see the same sort of demo for other atomics, you can do that there.
Yeah,
and you can
that's
see that
awesome.
on our Antisyphon YouTube channel, and I dropped the link to the playlist in the chat, so you can find it in our Discord if you are driving, Mike, and not able to click on a link.
All right, awesome. This was great. Thanks for coming on and sharing with us today about Atomic Red Team.
Yeah.
Thanks.
All right, we're going to end it here. I'm going to tell myself to kill it with fire. Thanks, everybody. We will see you next week on AASLR. Bye.
Bye.
Killing with fire in 3, 2,